Okay, we're going to take a look at a graph of a function. We're going to start analyzing it. We ask some questions like where, as we go left to right, we're going to mark like what intervals, like let's say a function might be increasing or decreasing based on, kind of consider the x-axis a highway and kind of like these x coordinates, the mile markers. Like this point here from -6 to +1, this function is decreasing. It starts out up here and it keeps getting lower and lower and lower. Okay, and so we would say this function is decreasing on the interval from -6 to 1. We're kind of marking the x-axis kind of like a highway and consider these mile markers. So this function is decreasing from -6 to 1. And also it's decreasing from 4 to 6. Notice it's as these y values look at my y values as my y values of this graph are going from 2 down to 0 here. So it's also decreasing on the interval from 4 to 6. We talk about a decreasing function as let's say like this point here, let's say that's x1 and that's x2. 4 is less than 6, but notice my function at my first point here is greater. The function of that value, the output, is greater than this. It's 2 and it goes to 0. So that's kind of the definition of a decreasing function. Okay? An increasing function, this function is increasing. Notice, let's call this point x1 and let's say this point is x2. Notice x1 is less than x2. That means x2 is to the right, obviously. If x1 is less than x2, x2 is to the right. Notice a function is increasing if the output of the left coordinate, let's say this one right here, is less than the output of x2. Okay, so notice this output here is less than this output. So that's increasing function. So we're kind of go left to right as if your y values go up, you're increasing. If your y values go down, so notice we're increasing on the interval from 1 to 4. Okay, so we could write that 1, 4. We're decreasing on two different intervals from -6 all the way to 1. Okay, and also from, let's see, 4 to 6. Okay, so from 4 to 6 is we're decreasing on those intervals. So we kind of use the x-axis to mark. Let's talk about relative or local minimums or maximums, okay? Relative or local would be kind of just when we focus in on a given interval. Let's just say from 2 to 6 on the interval from 2 to 6 on this interval, I have a relative maximum or a local maximum at x equals 4, and the coordinate would be 4, 2. Okay, this point, it's relative or local because it's not the greatest for the entire function. This point here is actually higher, but on this certain area here, let's just right here, this local area on a given interval from 2 to 6, that's a relative maximum. That's the highest value I have. Okay, I don't have let's see. Well, let's talk about over here. On this interval, this would be where we bottom out here, let's say, at this point here. This would be a local or relative minimum on the interval from, let's say, -6 to 2. This is the lowest value that I have here, and it's at point 1. It occurs at x equals 1, and the coordinate is 1, -3. That would be the coordinates of my local or relative or local minimum. Okay, you're going to have a relative or local minimum when you have a decreasing function and then it changes to an increasing function. Okay, decreasing to increase. When I have a change, basically a negative slope to a positive slope, I'll have a local or relative minimum. I'll have a local or relative maximum when I have an increasing function and then all of a sudden a decreasing function. So the slope goes from positive to negative. Okay, all right. So that's when we talk about local or relative, it's over a specific interval. When I talk about the entire function, if I want the max value, this value right here, which occurs at x equals -6, and is going to be the point -6, 4, that is my absolute maximum. Over the entire function, that is my absolute maximum, okay? So absolute min or max are over the entire function, the function's minimum and maximum value. This right here is my absolute minimum. So you can be also, this is not only a relative minimum here on this interval, it's also the function's absolute minimum, okay? So local or relative mins and max are over a specific period where we have a change of slope from negative to positive, where we're decreasing function to increasing. We have a max from increasing to decreasing over a certain interval, but an absolute maximum or minimum are for the entire function. This happens to be the absolute minimum and the relative minimum. It occurs at x equals 1, and you have the coordinates. Here's my absolute maximum, okay? Let's talk about, finally, concavity. Areas in the graph where you have concave areas. And we're going to have either concave up, which is a smile, or concave down, which is a frown. Concave down is a frown, okay? So we can ask, where are the intervals, let's say, on what interval is this graph concave up? Well, this is part of a smile here. So from -6 to -4, I'm concave up. This is what's called an inflection point, where the concavity changes. I go from concave up, from a smile to part of a frown. That's an inflection point. So I'm concave down from -4 to -2. That's a -2 right here, okay? And here's another inflection point where my concavity changes from concave down, from a frown, and all of a sudden this is a big smile. So I'm concave up again from -2 to 2. And here's another inflection point where we go from concave up, and all of a sudden I start the frown. So we've learned about concavity, and again, we're asking a lot of things over what intervals this occur. What intervals on the x-axis do we have a decreasing function, an increasing function? I'm concave up from here to here. I'm concave down from -6 to -2. I'm concave up again, smile from -2 to +2, and I've got a frown, concave down from 2 to 6. Okay? And we've learned about inflection points, point where the graph or function changes concavity, okay? All right? I've got one here, here, and here, okay? I want to introduce one more thing, the issue of a function being bounded or boundedness. You can have upper or lower boundaries. Here's an example of a function that's bounded below. I've got a min value, I've got a boundary here. Basically, this graph won't get any lower than right here. So I have boundaries below on the lower part of the graph, but it's not bounded above. This graph just goes on to infinity above. So here's an example where a graph is bounded below. Okay, it has a minimum value. It's bounded. Okay, but it doesn't have a top maximum value, so it's only bounded below. Here's where something's graph bounded above. Okay, I've got like a max value. This kind of goes down, up, down, up. So I've got a boundary on the top of the graph, but these values seek negative, the minimum value seeks negative infinity, so I have no boundary below. So this graph is bounded above, but not bounded below. Here's a graph where I've got probably horizontal asymptotes at like y equals 0, but I have both an above, and it's bounded both above and below. Okay, I've got a boundary above and below. I've got a max value and a min value for this graph. Okay, and finally, I've got one more thing. Here's something here's y equals x cubed. It's not bounded at all. It goes to infinity and negative infinity for my range, so it has no top. It's not bounded above or below. Okay, there's no boundaries. All right, we're going to analyze tomorrow. We're going to analyze graphs like this and talk about, there's an inflection point, there's a relative min, etc. On what intervals is this increasing or decreasing? Okay, that's all I got. Enjoy.